We are now in section 2-4. This is the last section of chapter 2. The title, Paired Data and Scatter Plots. Many times researchers are interested in determining if a relationship between two variables exists. In order to accomplish this, the researcher collects data consisting of two measures that are paired with each other. For example, researchers have found that there is a relationship between the temperature and the chirping frequencies of crickets. As the temperature increases, so does the chirping frequency of the crickets. It is a very tiny section, but lots of stuff is going on. It says here they're going to be paired, we're going to have different pieces. I know we've mentioned this before, but I'm going to stop and draw it again. The x-axis is going to be the independent variable. It's going to be the independent axis. Explanatory. It gets multiple names. I'll go ahead and say explanatory. It's the variable explaining what's going on. Another word in science, and I've got to be real careful with this one because we are not actually going to use that word, but sometimes it helps my students to see this piece and that piece. So if this is independent, over here on the y-axis is going to be dependent. And here you see several things are underlined. And then if it's independent and dependent, the explanatory variable is going to be resulting in a response variable. Now again, I'm going to say this word and I'm going to scribble it out. In science, you have cause, and then you have the effect on that cause. I need you to see that this is the x-axis, and it is going to be like if I use 1 gallon of gas, then I have gone 24 miles in my car. If I use 2 gallons, I have gone. And so depending on what I do over here is going to impact, have a result, have a response with what's going over here. But this little sneaky word right here, we are not going to use that word unless we do what's called an experiment. In other words, we're going to have to be real careful when we are just doing observation, and then when we're actually going to be manipulating our variables with a control group. We will get into that. We touched on it already. I'm going to erase that word cause. I'm going to erase this word effect and go back to the original. Independent, dependent, explanatory, response. It says there's going to be a graph, and we're going to call it a scatter plot or a scatter diagram. So one more index card for this chapter. It's a graph of ordered pairs. Ordered pairs, here's an X, here's a Y. We're going to have X and Y of the data values, and it's used to determine if a relationship exists. It may be a relationship, but you see this little word we just scribbled out? We don't get to say that word there. Anyway, moving on. I'm going to go ahead and show you what I've got written. Correlation does not imply causation. Just because something looks like it's got a relationship, you cannot just say this causes this. We will get more into that as we get deeper into this book about when we're allowed to say something as a cause. We're going to have a whole lot of stuff going on. Confounding variables. Is it really an experiment? Is it really just an observation? What's really going on here? For right now, you and I are talking about paired data and scattered plots. We are going to note in a big way that correlation does not imply causation. But we're going to talk about these scatter plots. They can have positive, linear, looks like this one. Like it appears to be going up in a line. The dots are not connected. I called it buckshot, and I had a student correct me and say it was dove shot, where it just looks like it's splattered across with the pellets. We're not connecting the dots. It could be that it's negative. In other words, instead of going up, this could be going down in kind of a line. Nonlinear means it doesn't have any kind of pattern. It's just a big old mess. And I say that, and then it mentions like it's falling in a curved line. And so you see this nonlinear, and you see no relationship. We will have names for these, no discernible pattern. It's kind of loose with what we say. We're just trying to describe. Let me keep reading. The relationship between the variables in this 217 appears, and so we need to go find this, appears to be a positive linear relationship. Oh, it's someone up here. It appears. And so on your index card, make sure you've got words like appears, seems like, could be. But this relation appears to be a positive linear relationship. In other words, as the number of wet bike incidents increases, so the number of deaths that occurred because of these occurred in these accidents has also been increasing. More information on all of this, scatter plots, correlation, regression. We're going to get to it. We actually are going to go chapters 1, 2, 3, and then straight to 10 because it all goes together. And then there are more pictures. So let's go ahead and talk about what they were saying on this other side, where we saw positive linear, negative linear, non-linear, and then this no relationship. So looking here, as you look at this one in this top left corner, it appears that as we go across the x-axis, it appears that this looks line-ish and that it's going up-ish, and so we can call it positive. As one goes up, the other goes up. It's a positive linear. It appears to be. When you look at this next one, it appears that as the x goes up, the y goes down. That would be a negative relationship, and it looks line-ish. So we can say negative linear. I'm going to go ahead and jump to this one. This one, you can look at it and say, I don't see anything going on. We will put some numbers of correlation on these later, and we will talk about zeros and negative ones and ones. But for right now, this doesn't look like it's doing anything. These look pretty organized. Like when hurricanes are coming in, they're organized in circular patterns. This looks like an organized line, an organized line. This looks like a mess. This, it's not a mess, but it's not a line. And so we're going to specifically call it not a line, and we'll be fancy and call it nonlinear. For this section, I highly encourage you to work on this. I always have do if time if we get to do it in our class. This is what I would highly encourage you to work on. Remember, all of the answers are on page 115, and this concludes our section 2-4 in our statistics class.